We've been at the forefront of automotive engineering innovation from the beginning, from the Model T to the fully autonomous vehicles of today. With the next automotive revolution happening right before our eyes, SAE's quantifiable research and reliable technical documentation are more crucial than ever. Connected vehicles, electrified vehicle technology, and sustainable transportation are just a handful of the areas where SAE International supports those who shape the future for the mobility of tomorrow. With more than a century of experience, a powerful and growing cohort of shared knowledge, backed by a global community of more than 200,000 engineers, technical experts, and volunteers, SAE continues to curate the most reliable and comprehensive collection of engineering resources and consensus-based mobility standards on Earth. Movement defines life. SAE lives to define movement.
Welcome, everyone. I'm Tabitha Colter, Director of Operations at PAVE, Partners for Automated Vehicle, and I'll be moderating today's panel. Thank you all for joining us today and to SAE Detroit section for hosting this event. Today, members of the Cavenu team and Toyota will be discussing the future of roads, designing supportive/safety infrastructure at the corridor level. For this discussion, we're looking forward to questions and input and ask you to please use your chat function at the bottom of the screen to send questions so that we can address them. Talking with us today is Dave Clifford, Head of Strategic Innovation at Cavnue, Dino Nardicchio, Head of Automotive and AV Partnerships at Cavnue, and Paul Fanson, Senior Manager at Toyota Motor North America R&D. Welcome, Dave, Dino, and Paul.
Thank you, Tabitha.
Thank you, Tabitha.
Thank you guys for being here today, and let's go ahead and get started with the presentation.
Great. So I'm Dave Clifford from Cavenu, and we're going to be talking today about some of the work that we're doing here on designing supportive and safety infrastructure at the corridor level. So here at Cavenu, our goal and our aim is to simplify and enhance the driving environment, really looking at enabling safer roads that are more efficient for all users and help in improving mobility access. And we're looking specifically at how to enable automated and autonomous vehicle technologies at scale using changes in civil engineering, modifications to the built environment, as well as novel hardware and software approaches to enable predictive operation of those roadways. Why, right? Why would someone be interested in doing this? So there's, I think, four major value propositions that we're looking at here for the diverse set of stakeholders that use our roads today. The primary goal is to help the traveling public move around, whether this is people who are stuck in a commute and spending hours a day driving to and from work, or people who are stuck in traffic delays who want to have a less congested roadway and a more efficient roadway at a higher service level, or people who don't have a driver's license, people who need to get from one place to another and either don't have a driver's license or don't have a personal automobile that want new transit alternatives to be able to move around places where there aren't robust infrastructure for transit today. We also look at helping OEM and AV companies accelerate their ability to deploy automated driving and autonomous vehicle technologies that frequently have to deal with today's roads and today's weather and today's drivers. And we want to figure out ways to improve the ability of those organizations to put technology on the roadway that operates in a safe and efficient fashion. The third people we want to help is departments of transportation and policymakers, because these are the folks who today operate most of those rights of way. Most of the roads in North America are operated by DOTs using federal funding in many cases. And these DOTs have goals to improve traffic safety, reduce fatalities on the road. They have goals to be able to improve the lives of people who live in their catchment areas, which is a transportation engineering term that means like zone, right? Live around the areas that these metropolitan planning organizations or these states have plans for roads. They want their roads to carry more people in less time with less wear and tear on the road. And ultimately, improved congestion, improved safety, And electric vehicle adoption helps some of these states meet climate targets and help the federal government meet climate targets by reducing emissions and improving things like electric vehicle adoption. Last, there are road operators around the United States. My wife's from Delaware, and every time we go and visit her family, we see the Delaware toll booths that a lot of you, I'm sure, are familiar with. And a lot of those road operators, they want to make sure that they're able to collect revenue from their roads to allow them to make reinvestments in their roads, whether that's investing in new technology, like some of the technology that Cavnue is bringing to market, or whether that's looking at things like maintaining some of those critical bridges and tunnels and other pieces of infrastructure. So how do we do this, right? When we think about roads in the United States, we think about typically these three different domains, these three different sorts of roads that make up what we call, and what everyone calls, the National Highway Planning Network, the NHPN. And roads that are in the NHPN typically fall into one of three categories. They're highways or motorways. These are things like in Michigan, I-96, I-94, I-75. Some of them are arterials, places like Michigan Avenue. And in other cases, they're downtown urban environments, right? You think about, I'm Dave Clifford, so I always like to think about Clifford Street here in downtown Detroit, right? And these different sorts of roads have different operational characteristics that today, local drivers, vulnerable road users, and automated and autonomous vehicles want to be able to gather more data about. So really we think about if these different roads and these different road types could talk to the users of the road, what would they say? And a lot of what Cavenu looks at doing is trying to figure out ways to get the roads to talk to the road users and provide them that critical information that's needed to operate a vehicle in a safe and effective manner, to keep a road up to date from an infrastructural investment perspective, to avoid those delays in traffic. On a highway, we think about how to create and instrument the highway so that we can get long looks over broad sections of corridor and still be able to understand the vehicle dynamics and what's going on the road surface so that we can inform drivers as to what's going on these different segments of corridor. And we work on this through taking approaches from both machine learning, which allows us to understand things like the vehicle kinematics, what's going on in areas where our sensors can see or detect vehicles moving on the roadways, and also data science. You can understand the kinematics of what's going on the road, but that doesn't tell you whether or not things on the road are normal or abnormal. So for some of those normal, abnormal, hazardous, not hazardous, we look at taking these measures of vehicle kinematics from that corridor level and comparing them to known events from the historical past, so that we're not like, day one, we want to learn how roads work. And a lot of that is bounded by some of the principles of traffic engineering and civil engineering that have come prior to Cavenu, where we're really looking at how we can build on top of those things to come up with these next generation designs for how roads can successfully talk to people. In arterials, we continue to look at these broad stretches of road because these are multi-lane roads. Some of them have corridor speeds in like the 45, 55 mile per hour range. But in the arterials, there's a lot more concern around what's going on at an intersection, as well as what's going on with vulnerable road users on the roadway. On highways, we still care about pedestrian detection, and we care about understanding, people who are on the highway that are outside of their motor vehicle, because we want to make sure that those people are safe. But in arterials, we want to look at how we can deploy technology to guarantee those road users' safety. We think about a lot of the advances that have been made in VRU protection as a result of the advocacy work in the cyclist community, and how can we expand upon that and make sure that that intersection of safer streets for cyclists, safer streets for pedestrians isn't just a goal of today, but it's also a goal of the future as we prepare these roads for autonomous vehicles, right? How can we assist OEMs and automotive manufacturers and autonomous vehicle organizations with building capacity on streets to make sure that those vulnerable road users are safe on those streets? And this becomes more important in the denser urban environment, where we really want to look at areas that are lower speed, right? And where there's not as much opportunity for cameras to see or for sensors to see as far as they might be able to see on these broader, clearer arterials. So in those denser urban environments, the ability for an autonomous vehicle to see what's going on around a corner, or to see what's going on around at a complex intersection, or to be aware of some of the dynamics at those complex intersections becomes much more important. So, this is when, right? When are we going to do this? If you think about the history of the highway system in America, we really think about that history of the highway system in America starting with the investments that were made in the interstate highway system, which really began in the 1940s and the 1950s and extended through to a lot of the ways we think about roads in current day, right? A lot of the same principles of road design, those standards for safety, they've been set in place in the 1950s and then modified, right, throughout the course of the last 60, 70 years. When we think about autonomous and automated vehicle deployment, we think about this transition to this mixed traffic scenario where as people pick up and adopt these automated safety systems or these autonomous driving systems, it might be a human with superpowers that's driving in the lane next to you, someone who's got really great level 2 safety systems in their vehicle. And it might be, we're sharing the road in places like Phoenix or in places like San Francisco or Pittsburgh or in other areas where autonomous vehicle concepts are being tested. More and more we're sharing the road with these robotic drivers, where those robotic drivers and the human drivers and the vulnerable road users need to be able to have a better understanding of these edge cases, right? How should I expect the robot vehicle to behave in fog, in snow, right? Where can the robotic vehicle see me? How can I be sure that it sees me there? And so we look at the Cavenu technology, our technology portfolio, as providing that better performance envelope for those autonomous vehicles and those automated driving solutions. When we move forward into stages of higher penetration, we think about creating restricted access thoroughfares, places where autonomous vehicles can operate in a safer corridor, in that broader safety envelope, and where we can provide additional benefit to those automated vehicles and to those autonomous systems, while still allowing humans and enabling human road users, whether they're vulnerable road users or human drivers, to get additional benefit of some of the hazard awareness and some of the other technologies that we're using to allow the road to talk to these various stakeholders. And then eventually, as we see a future where automated driving solutions and autonomous vehicle solutions become more widespread and commonplace, many of those benefits about safe, coordinated driving, we feel can be most efficiently unlocked when it's the road that's informing the various stakeholders, rather than relying on a system where a Ford car and a VW car and a GM car and the other entities' cars all have to talk to each other through a broker. So we think that the road instrumentation and the roadside instrumentation is a critical enabling technology to allow these for the emergence of some of these principles of coordinated driving without relying on standards to become emergent between these automobile manufacturers and the automotive companies that are operating today. So maybe this is going to be a little bit more tangible for those of you who don't think about problems that robot cars have every day. I've been thinking about problems that robot cars have for 17 years now. So I think about how robot cars have challenges for a long time. And this is a good example of a sort of scene that's challenging for a robotic car today. You've got a complex downtown intersection, right? It's snowing. There's a green light. There's a bicyclist who's engaging in a behavior that we call shoaling, which is a bicyclist that's driving in the right of way, where the bicyclist has, eligibility to operate. and is trying to drive in a way and trying to operate their vehicle in a way that's safe for the cyclist, right, in this kind of complex condition. The crosswalk is obstructed, so it might be difficult for an automated vehicle system or autonomous driving system to see where that crosswalk is, to understand maybe where they should be looking for pedestrians. And in these snowy conditions, the light bulb itself might become obstructed, and it might be harder for the vehicle to read what's going on in that traffic light. So how does Cavenu help with these sorts of problems? And the answer is we simplify things, right? So in this case, we're looking at creating a delimiter, right? You can see this delimiter here in the next to the autonomous vehicle lane that acts as a cushion for occupants that might be encroaching on the area where a robotic vehicle might be operating. We look at providing hazard notifications about slippery surfaces on the road ahead, right? Not just that it's snowing, but that snow and ice might be forming on the roadway. For those of you in the Detroit, Michigan area, there are a lot of times when it'll be 40 degrees out and snowing here, right? This is a hazard of life. But we want to be able to make a distinction between snow that's going to melt as soon as it hits the road surface, and snow that's going to accumulate and cause a hazard. We're also able to monitor the crosswalk, like we talked about earlier, so we can provide broadcasts out to the vehicles that the crosswalk is clear and that the light is green, right? And all of these things are beneficial for autonomous vehicles and automated driving systems so that they don't have to attempt to interpret these complex scenes around them on their own, right? We're trying to enhance the ability of autonomous vehicles and automated driving systems to navigate the environment. And luckily for us, it would be one thing if we were doing this on our own and we had a bunch of people who come from some of the great institutions that our team comes from, coming up with these ideas, but we're not on our own. We're doing this in partnership with many of the organizations that are looking at deploying automated vehicle technologies and autonomous systems today. That's why Paul was gracious enough to join us, and that's why Dino, our head of automotive and AV partnerships, is going to be talking a little bit about how we interface with those other members of the community from those OEMs and those autonomous vehicle entities. So I'm going to turn it over to Dino.
Great, thank you, Dave. Before I get started, I just wanted to say what a great group we have with Paul from Toyota and Tabitha from PAVE. So thank you both for being here with us today. I'm very excited to be here as well and share more things about what we're doing at Cavenu. I'd like to provide an overview on one of the things that I'm most passionate about, and Dave just alluded to that, and I want to frame up what we call our advisory committee. And the reason why we established the advisory committee in the first place. We strongly believe that supportive infrastructure simplifies the complexity problem for autonomous vehicles, and Dave just gave some examples of what those were. We also believe supportive infrastructure will therefore help to fully realize the benefits of intelligent, connected, and automated vehicles. And so collaborating on roadway infrastructure design will create value in mutually beneficial ways for all. So we're very fortunate to have a broad and diverse group of companies on the advisory committee to partner with us and support the Michigan project that we are currently working on, as well as others throughout the country. We are excited for the opportunity to collaborate and explore mutually beneficial opportunities related to advanced technologies for roadway infrastructure. We're conducting our advisory committee meetings more or less on a monthly basis, and we are engaging advisory committee representatives on both technical and policy matters. And so fundamentally, we're looking to solve problems with the current infrastructure. It could be challenges with signs, traffic control devices, barriers, or more challenging scene risks and scenarios like some of the ones that Dave just talked about earlier. We're in a position with this advisory group to ask some very, I think, poignant questions. If you had a clean sheet of paper, if you had a magic wand, what would you do or what would you want from infrastructure? And we also have a steering committee in which this group convenes, I'd say, on a less frequent basis. And it's really more or less to discuss high-level tech, product, and policy matters. So the goal of the advisory committee is threefold. It's to share the progress that we're making in Michigan and in other projects in locations around the country. It's to coordinate on local, state, federal, and possibly even international transportation agencies and standard setting bodies. And then it's to ensure that our tech stack and the infrastructure solutions that we're working on will work with the vehicles that are on the road today and on the road tomorrow, and work with their on vehicle systems. So this includes identifying the minimum technology thresholds that vehicles need to engage the corridor. Many of the production vehicles have advanced driver assist features that provide longitudinal and lateral control through technologies such as adaptive cruise control and lane centering or lane keep. That makes these vehicles capable of partial automation or level 2 automation. We also want to identify what are the essential infrastructure capabilities that we need to provide, and really ensure that the solutions that we bring to the roads are compatible with ADAS and AV platforms in order to enable not only current but future vehicles to engage the corridor. So as I mentioned earlier, Cavenu is really seeking to advance neutral industry-wide standards and to make technology decisions that are not tailored to any particular OEM or operator. And we call this OEM neutrality. Open certification, which basically means we will not preferentially treat any particular OEM. And any OEM or AV provider that can successfully undergo a neutral certification process will be able to operate their vehicles on our CAV lanes. And we're seeking feedback from our advisory committee members, not only on the development of our technology, but our infrastructure strategy and even our planning. And basically, we're looking for some visibility into relevant roadmaps that can help us develop the compatible technology for everyone's benefit. So to sum up, there's a number of benefits of having this advisory committee. First and foremost, it's addressing challenges and pain points with current infrastructure that helps support current and future automated driving systems, and interoperability and coordination amongst multiple vehicles sharing the road. With respect to the communities we serve and the governments we support, there's interaction with regulators whereby we are informing infrastructure development by municipality and state DOTs. And we truly see ourselves as serving as a bridge between the mobility industry and government. And finally, we more succinctly believe we can help accelerate the development and deployment of connected and automated vehicles. So with that, I'd like to hand it over to Tabitha, who I believe may have some questions for us. Tabitha?
Thanks, Dino. Thanks, Dave. That was a really useful presentation. Yeah, we'd love to kind of dive into some questions and hear more from all of you. So Paul, I'd actually like to start with you and ask you a question about how private companies like Toyota are participating in efforts to prepare for AVs, projects such as this Cavenu corridor project in Michigan.
Yeah, thanks, Tabitha, and thanks again to Dave and Dino for your great presentation. And it's, of course, a pleasure to be a part of this project and to be working with both of you. I guess to answer that question, it touches on a lot of some of the things that Dave and Dino said, which is that from an automotive standpoint, we're primarily focusing on the automated part of this project because, it's sort of contained within the vehicle. It's what we can control. And, we're designing vehicles that in theory can go anywhere and sort of handle any situation. But clearly, there's still a lot of technical gaps before we can achieve that very stringent goal. There's still a large number of edge cases that are going to continue to cause automated vehicles problems. And so, we're not really going to wake up tomorrow and have Kit from Knight Rider, and hopefully there's people on the call that get that reference, in our garage anytime soon. That's still quite a ways away. But what I think we are going to see is a sort of series of incremental improvements on the automotive side that will make driving safer and more convenient. But that's going to involve a fairly large suite of hardware and software packages. It's a large number of sensors and complicated software. Those are going to be expensive. It's also going to be energy intensive, which I think is something that doesn't get discussed very much. And so there's still a lot of barriers, basically, in order to really make this a very ubiquitous solution. And so, and along with that, there's also customer acceptance, which is not clear, quite honestly. And certainly, I think there's some customers that'll buy this as soon as it's available, and there's others that won't trust it. And so when it comes down to infrastructure projects such as Cavnue, as was mentioned, there's a lot of potentially complementary technologies that infrastructure can provide that will make the overall driving experience easier and more efficient. And so we believe that this type of project only helps to accelerate the overall advancement in automated and connected vehicles. And I mean, ultimately, the customer doesn't care how we get there. The customers don't care if it's automated, if it's AI, if it's communicating with the infrastructure, it doesn't matter. So it's really just about providing the solution that is going to be the best for our customers. And we think that we can help do that sooner by working with companies like Cavenu in order to work on that infrastructure part. And of course, the sooner we can deploy this technology, that also helps to build customer acceptance faster. And so these proof of concept projects are very important from that point of view. But ultimately, it is a chicken and the egg problem with infrastructure. Again, auto companies deal with the vehicle, but vehicle connectivity by definition is collaborative. It's a collaborative exercise. And so these types of collaborative, somewhat pre-competitive, I think that word's appropriate here, projects are very important in order to solve that chicken and the egg problem. And so I'm very proud to be a part of this project and provide kind of Toyota's point of view and how we can work together with Cavenu and with other OEMs. And I'll just say that also as a native Michigander, I'm very proud that this project is taking place in Southeast Michigan. It's always been kind of the capital of automotive technology, and I think it will continue to be so. So I guess that's all I have to say for now.
That's great. Thanks, Paul. Dave or Dino, did either of you guys want to add anything to what Paul was talking about there about the relationship with private companies?
I think Paul, we're really happy to have people like Paul on our advisory committee. And I think, I've been fortunate to be able to participate in a couple of the conversations that we've had, that Dino's led. And it's great to see folks from across what's normally and continues to be a really competitive space, right? Autonomous vehicles are really a race, coming together in one room and talking about areas where they do have these common challenges. Autonomous vehicles might be a race, but signs and signage aren't a race, things like that. And so it's good, and it's been a real pleasure to participate in these organizations with folks like Paul.
Yeah, I would echo that too. I mean, we're very fortunate. I mean, when you have this group in a room talking about some of these challenges, it's great to see the collaboration that we are able to foster across all these different, not only companies, but even driving systems. So it's been extremely beneficial for us to be able to partner with these folks and to work with them as closely as we are.
That's great. Moving on to a next question. Dave, this one wanted to direct at you, but in terms of the infrastructure, could you describe some of the technologies that the Colter project is implementing, specifically maybe some of the benefits of those technologies?
Sure. So for a long time, I've had a background in technology, and one of the questions that I've always looked at is, what's the outcome that the technology is driving towards, right? You can make a really cool new polymer, but if that new polymer doesn't provide a consumer benefit or a benefit to people's lives, it's a science project, right? And a lot of what we're looking at Cavenu is taking things that, have been developed and invested in. We didn't come up with convolutional neural networks, right, as one example, but it's great to be able to benefit from them. We didn't come up with safety critical silicon. The safety critical silicon came from long partnerships with some of the chipset manufacturers and the OEMs. But it's great to be able to benefit from it, right? To have a reliable chipset controller when we're thinking about how we deploy devices to the edge in the field. So let's talk a little bit about some of those outcomes, right? We talked about having technology that helps road operators understand areas of congestion, but also having them have better ground truth as to why the congestion occurs in the first place. In many cases today, corridor operator might have a sensor at one place in the field and they see the outcome, the congestion, but they don't necessarily see the cause of that congestion. You know, we're looking at how we can help these vehicles see further. Sometimes when you look at a map, roads appear to be flat, right? There's a lot of roads around the country that appear to be flat, plain surfaces, and then when you drive them, you realize that they've got pitch to them, right? That the camera that you thought was going to be on a vehicle where you could see 200, 300 meters down a 65 mile per hour road, now because of the way that that camera rolls through space, you really want to complement to be able to see some of these things that are substantially ahead of you or around a corner. And there's only so far that a single photon can fly, right? On the planet Earth, it is a sphere, regardless of what some people on Twitter might believe. One of the areas that I'm really excited about, though, in all of this is in technology that will allow us to accelerate incident response. And I'll tell you why. Before I worked at Cavenu and before I worked at General Motors, I worked in helping the military develop some technologies that improve medical care and trauma response. And one of the huge lessons learned in that field was the importance of first response. Basically, the faster you can get a first responder to the scene, the better the outcomes are going to be. So when we're thinking about instrumenting these corridors, one of the major benefits is in our ability to detect those incidents in near real time. And one of the outcomes from that, of course, is to help us understand how to redirect automated or autonomous vehicles away from those incidents, but it's also how to enable those first responders to get to those incidents on time. And I think that's a huge benefit that we can bring really early on to some of these projects in Michigan and other places where we're looking at working with road operators to deploy these technologies. And I think that that's a major positive outcome to help road safety in early stages.
Definitely. And I know one of the things that's most interesting to me personally about infrastructure is, you know, the element of the local consideration that comes into projects like that. You know, driving policy is tuned for local traffic, vehicle form factors serve local needs, deployments have to target local mobility challenges, social needs, et cetera. So I'm curious, you know, what are some of the unique local needs that Michigan hopes to address with AV, and how are they affecting your work in the Cavenu corridor? Dave, I think you might start off with that question.
Yeah, I'll start out, and then I think Paul, as a proud Southeastern Michigander, right? Maybe you can add some color commentary, but I don't want to put you on the spot. So in Southeast Michigan, we think about, you know, our partners at MDOT, who are really truly partners in this. They're enabling and championing this vision for the future of roads. And as those champions and as those partners, their concerns are fortunately shared with Cavenu, right? There's the desire to have improved transit and mobility options. There's a desire to support economic development in Michigan. And of course, there's this desire to enable road safety. For Cavenu, we have the opportunity to be part of a really exciting effort along Michigan Avenue, working in the community and with the community. One of our staff members is, you know, also a resident of the Corktown region along Michigan Avenue, and she's super gung-ho about how some of the things that we're looking at deploying are going to bring benefit to the community around here. And to create this mobility corridor, which we think will drive economic development along with, you know, some of the other investments that are being made in Michigan Avenue in the city of Detroit, which is a wonderful place to live. And so that's one big part of it, where we're looking at that mobility and economic development components to this effort. One of the other things that I think is really important about doing work like this in Michigan, and doing high-tech autonomous vehicle development and automated driving systems development in Michigan, is that in Michigan we have weather, right? For those of us living here in the summertime, we have a lot of weather and very varied weather. And weather presents unique and complex challenges for all drivers, whether they're autonomous and automated vehicles or just human drivers. I can tell you personally that there are nights in January where I've been driving from DTW back to Detroit, and you see cars on the side of the road waiting for a plow or waiting for a tow. And I think that some of the early work that we can do in instrumenting I-94, I-96, and providing better weather awareness on some of those events around the corridor with our partners at MDOT, is substantial as one of those early benefits.
And Paul, I think Dave wanted to put you on the spot a little bit there too, to talk about those unique needs of Michigan and how these projects work towards them.
Well, I guess I just have a little bit to add to that. Well, first, I'm not originally from Southeast Michigan. I'm more from mid-Michigan towards the Lansing area. I actually grew up in rural Ingham County, but that notwithstanding, of course, Detroit is still, the sort of, I hate to use this term, but kind of crown jewel city of the state. Like, this is the center of gravity for the state of Michigan, and it's still a city and there's still a lot of civic pride that I feel for the city of Detroit, having, despite, living a little bit west of there my entire life. And so for me, it's exciting to, I think we all know that the city of Detroit has gone through some rough patches, obviously. And so to be part of a project that can help to revitalize the city, I think is very exciting. And I very much see that this is a project that can help to revitalize it. And I guess the only other comment that I would make is Detroit specifically has somewhat of a unique history that I don't think this is untrue, so I will say it, that it was basically designed for cars. Like, there was kind of almost an intentional choice not to put a lot of public transit in the city, because we're the motor city, right? We're supposed to drive our cars. And, that's great. But at the same time, it maybe doesn't serve the needs of all people as well as it should. And so if we can provide some additional mobility or transportation solutions for people, and have it be more inclusive and more equitable and fair and all those good things, then I think that that's also a major positive. And so that's another thing that I hope that we're able to achieve through this partnership.
That's great. And we had a question from the audience I actually wanted to go ahead and address. Bill asked, is Cavenu providing input to the new infrastructure bill that's being introduced in Congress? Dave or Dino?
So there's a lot of infrastructure bills being introduced in Congress. And I think that as we look at the priorities of Congress folk and the priorities of the communities that those Congress folks serve and the priorities of the administration, that one of the things that we're grateful for opportunities like this to be able to do is to be able to do more around talking about how these sorts of technologies and these sorts of enabling solutions can be part of infrastructure solutions, whether those infrastructure solutions are solutions that today's states and today's state governments are sponsoring. We're lucky to have really strong partnerships, like we said, with MDOT, or whether there's choices that legislators and executive champions make to enable continued investments in infrastructure. I think we're happy to be parts of those conversations.
And actually thinking about that development side of AVs and as they're going through, Dino, I had a question for you, which was sort of asking whether AVs, should they be designed to get 100% within existing infrastructure, or are there design options that could help with the readability of the street on that front end?
Actually, that's a really good question, Tabitha. Our goal is to create design solutions and options that improve automated and autonomous vehicle operation in the corridors. And really, we want to do so in a way that doesn't require any changes to the automated systems or autonomous vehicles. I think as our adoption increases in the future, hopefully, as we see more and more corridors that are configured the way what we're going to be demonstrating in Michigan. And so as this solution set increases and the adoption increases, we think there's an opportunity for vehicles to perhaps use or need less tech on the vehicle side and to still operate safely and reliably in an automated or an autonomous manner. We stated in the presentation, we're looking to simplify the operating design domain, for all automated and autonomous vehicles. And, we've had a number of discussions with our advisory committee regarding, the traditional infrastructure that I mentioned, the assets like signs and traffic control devices and barriers. But we're also looking at really, really challenging scenes and scenarios that can really help benefit everyone on the corridor. So including information about, vulnerable road users, the road hazards and weather conditions. So, we really are trying to establish an environment that can allow everybody to be benefited. And so we're not asking any of these vehicles to do anything extraordinary to be able to use our lane.
That's great. Well, I'd like to pivot the conversation just a little bit and talk about, money, of course. So Dave, infrastructure investments are expensive. So I'm really curious, how do you plan to bring all the things you've talked about today into new infrastructure projects?
Sure. So all technology has an end of life, right? And so in the same way that, a laptop might have an end of life, asphalt has an end of life. And all of civil infrastructure has an existing refresh cycle, right? That's why we see construction crews out patching potholes or milling and repaving roads or, painting new stripes on the top of roadways. I think one of the major differences is in civil engineering technology and in software or computer engineering. In software technology and in computer engineering, a lot of the costs of technology have gone down, right? We see decreasing costs to implement technology. In civil engineering, despite new technology being put on the shelf, a lot of costs in civil engineering have gone up, right? So you might hit a 16-year refresh cycle to repave a road and be paying compound interest effectively. You're paying a higher rate than the rate of inflation for the basket of goods that makes up repaving a road. But if you look at the same amount of processing power, you're paying way, way less on the cost of that processing power, right? I think one of our major value propositions at Cavenu is how we can leverage those downward cost curves of, hardware, silicon, software to start to stabilize the upwards trend in the cost curve in civil engineering. Effectively, our value proposition is if we can improve the lifespan of asphalt through things like predictive and preventive maintenance, if we can help extend the longevity of a bridge by understanding where there are surface defects, then the investments in technology that we're making, which I think a lot of which are driven by some of the drives towards making, imaging sensors or systems on a chip cheaper through the investments that the automotive industry has made, then the investments in this additional technology that we're talking about for a Cav lane or Cav corridor will repay itself by starting to stabilize some of those upwards trends in traditional civil engineering costs. So I think that's one of the things that, excites me about coming to Cavenu is how can we use advanced technology to start to do a better job controlling some of these costs that are driven in the public sector today, and how can we help those public decision makers make better decisions about where they're spending a dollar and how they're spending a dollar. We certainly don't want to stretch already thin budgets. We want to help policymakers figure out how to do the right things today so that they can do better things tomorrow.
That was a pretty comprehensive answer, but I wanted to check, Dino, Paul, did either of you guys have anything to add on that topic?
I think Dave answered it well. I don't have anything to add for that one.
Yeah, I think, obviously today, infrastructure being such a hot topic, it's a great time for us to be able to show what's possible as we talk about investment and what technology is able to do.
Definitely. Well, we did receive another audience question, which I wanted to put out a reminder that if anybody else has any questions lingering, go ahead and put that in that chat button and I'll make sure we get it asked. So the next audience question we received was, are the corridors that are being developed, are they closed to public transportation, or how is the transportation mix being controlled on the corridor?
I think that's a great question. So I can talk about sort of how we think about the transportation mix being controlled on the corridor. And I think, both myself and Dino can talk a little bit about, how we think about public transportation and transportation providers on the corridor as well. So when we think about transportation mix being controlled on the corridor, I think our principal concern is this concept of headways, right? So headways are what are called frequently a safety surrogate. Headways are the distance between any two vehicles on the corridor, right? And as we think about how we want to limit congestion and ensure safety, one of the things that we work around is having spacing between those vehicles on the corridor. So for us, as long as the traffic is flowing at a regulated and safe rate, it's not a question of who's able to use that corridor today, as much as is that corridor behaving in a manner that we would consider to be safe, and is the corridor behaving in a manner that we would consider to be safe in the future, right? Highly congested corridors start to become more, I'll use a physics term, entropic, a little bit less predictable, and as a result become a little bit more unsafe. So really it's not as much of an issue in early stages in terms of what type of vehicle, whose manufacturer, et cetera, et cetera. Again, this is a public right of way that we're looking at figuring out how to facilitate operations of, as it is an issue of making sure that that corridor behaves in a safe fashion. One of the components of the origin story of Cavenu, as Paul has talked about and as Dino has talked about, is the ability for these technologies that enable autonomous mobility and automated driving solutions to be enablers for transit alternatives. And when we think about those transit alternatives, one of those transit alternatives some of those transit alternatives include public transportation concepts. So, Dino, do you want to cover off on some of the work that we're doing on public transportation, or I can talk a little bit more about this here?
Yeah, go ahead. I mean, yeah, please.
So, there's organizations today that develop 2-person, 4-person mobility concepts. There's also organizations that look at 8 to 12-person mobility concepts. And there's organizations that look at things like automating and improving bus and bus rapid transit. So when we think about the ability for a bus rapid transit provider to engage in this corridor, whether that's a BRT provider that's provided by someone like Wayne County or the city of Detroit, or whether that's a transit provider that's facilitated by things at the state level, what we want to do is we want to make sure that those people who are advocating for better access to transit and the folks who are developing those automated transit alternatives have a natural place to come to with those alternatives, which is here in Southeast Michigan. What we don't want to do is, develop this great, rich automated vehicle corridor and somehow forget about the transit providers. So we're actively working with a lot of organizations that are developing transit alternative and mobility concepts and working to facilitate those conversations with the state policy decision makers that make some of the decisions around public transportation to make sure that those voices are on the table, both in the design phases and in the deployment phases.
Yeah, so we're very much working with, as Dave mentioned, a number of different companies that have different form factors, different models that they believe could help support public transportation. So we've got, to Dave's point, we've got vehicles that can safely transport 4 occupants up to obviously large city bus solutions that can transport obviously many more people than that. So we're trying to provide an opportunity for each and every one of these companies to have an opportunity to engage some of the DOTs and see if we can't come up with some specific solutions based on the particular corridor, its location in the city, and perhaps who are the businesses and the communities that they're serving and what's the best solution set for that particular stretch of road. So we're very excited to be able to do that and kind of be that broker, I guess, marriage broker, I guess, in some way, of getting these companies with these technologies to these communities. So it's very exciting. And we do, believe we're trying to provide, solution sets for all use cases that we envision using the corridor.
And one other quick note here, in the arterial cases where we're thinking about Michigan Avenue, one of the things that we're really looking at and deep diving in the design phase there is how to think about making sure that as transit operates, that a fun word I learned coming to Cavenu, the PUDOs, which is pickups and drop-offs, right, are safe, right? So we don't want to create a transit solution that drops someone off in an area where, now they can't figure out how to get to the sidewalk, or now they can't figure out how to cross the street. So really, looking at not just opening the corridor to public transportation, but thinking about the design elements that would enable those public transportation providers to make sure that the passenger experience that they're providing to their users is better, I don't say better, but advantageous experience that takes into account principles of best design.
Mhm.
Definitely, yeah, and that community integration is so important in what you're talking about, making sure you're designing for that intentionally. So PAVE, my organization at its core, is about public education and having those conversations with the public communities, everybody you're talking about. So I have to ask about, education and follow-up. So I'm curious, members of this audience today can follow up with this panel. Are there steps that they could take in their own work or their communities to push for that infrastructure development? Dino, let's start with you.
Well, I think there's a lot of opportunities for people to get involved in infrastructure development and in their communities. We, Cavnue, are participating in a number of events, not unlike this one, throughout the country to get not only the message out, but then to share some of the interactions we're having with different communities. And, I personally had a number of meetings with SAE as an example, just to discuss and understand what are the various task forces and technical communities that are available, that are focusing not only on AVs, but infrastructure. And I was absolutely overwhelmed as to how many are in place. And there's no lack of opportunities for people to get involved in either the product piece, the tech piece, the infrastructure piece, or even the policy piece for that matter. So there's, I think, a number of channels for folks to get involved with. I mentioned this earlier, but infrastructure is a big part of the national conversation these days. And, roads and infrastructure can be a very local issue. So I suggest everyone get involved in their communities and participate. I think these are great opportunities for people to get involved on a committee that I just mentioned, or something happening locally. I don't know if anybody else wants to comment, but I think there's a number of opportunities out there.
Yeah, I can maybe give a little bit more of a specific plug for SAE and some of the related committees that are in existence. I believe there's the Automated Vehicle Safety Consortium. I think that goes by AVSC, and that's already published some relevant best practices in this area. I think there's also the On-Road Automated Driving or ORAD committee. That's an infrastructure task force that's looking to develop infrastructure information to support AVs and also looking at human driver needs. And then there's a one that's just developing that I believe is called the Cooperative Automotive Driving System or CADS committee. And that's going to focus on, again, cooperative driving automation. That's going to enable vehicles to talk to each other as well as talk to the infrastructure, and then also looking at things like cyclists and pedestrians and using machine-to-machine communication in that regard as well. So I think any of those committees would be good ones to look up within the SAE context.
Great. And Dave, do you have anything else to add in there too?
So, when SAE initially talked with us about this panel today, one of the things that Dino and I huddled on was, as we're looking at great voices in the autonomous vehicle community, looking at PAVE as being one of the organizations that we really were excited to be able to bring into the discussion today. And so I want to say that for those of you who aren't familiar with PAVE and want to get a sort of layperson's guide to a lot of the topics in autonomous vehicles and how different stakeholders communicate to the public and do various forms of public outreach, that PAVE is a great resource for that. I'll also say that for folks who are interested and are really nerds about this stuff, I convinced many people on our team to start listening to the Autonocast. So I'll do a quick Autonocast plug, which is a fun podcast to listen to while you're driving about autonomous vehicle stuff. And then I think, as the Cavenu project accelerates and as we move forward, we're looking to be able to share updates and share more about what we're doing across the state of Michigan in various forums. So, I think that there's going to be a lot of opportunities for folks who are interested in this project to be more aware of things that are going on a month-by-month basis as our team grows and as the mission rolls forward. I'll also say that if this is an area that you're highly passionate about and you're either here today or maybe watching this on YouTube afterwards, that Cavenu is a growing organization, and we look to people from the SAE community to be thoughtful and be helpful, and in some cases, if you want to throw your resume into the hat or throw your name into the ring. We are a growing team and we're a growing organization. And if these things are things that excite you and ignite your passion, I think that's another great way to be involved. That's how I got involved, and I think that's how Dino got involved, right? So.
Great. Well, this has been a really helpful conversation, and I hope the audience has gotten as much out of it as I have. Thank you again, Dave, Dino, and Paul, for joining us for the conversation. And again, a huge thank you to the SAE Detroit section for hosting us. And to the audience, I just wanted to say as well, we really appreciate you joining us today. We encourage you to reach out to this section if you have questions, inquiries, want to get in touch with me or any of the panelists. Go ahead and send an email to that one that's listed on the screen there, events@saedetroit.org. Any additional questions or inquiries? We hope everybody has a great day.